Okay, this is a video loosely based on the topic of climate change. It's going to jump around a bit. Start with this picture. This picture is a great one. It's the Earth and the Moon in one shot, not photoshopped together, but both illuminated by the sun. Just a really nice picture, I think, highlighting the idea that all life on Earth is contained in this one little ball, on the surface even of this one little ball, and it's all interdependent on itself. So what we can see here are carbon dioxide and carbon monoxide. Mostly we see carbon dioxide emissions and concentrations in the atmosphere through a 1 year period. As we're looking at this 1 year period go by, we can see some things, like we can see regions like in China or in the eastern US or in Europe where lots of carbon dioxide is being emitted. This is wintertime. It makes a lot of sense that in the northern hemisphere we're burning a lot of fuel. We got to heat things, we got to power things, and coal is at least currently, a cheap way to do that. The reason that I've got this playing is mostly to highlight a couple of things. One is the fact that our emissions are spreading across the entire globe, right? If we're burning coal, or if China's burning coal, or if Eastern Europe's burning coal, it's not just their air that's being affected, but everybody's. We're coming now into, we're in May here. Down at the bottom, we can kind of see the date. I've cut it off a little bit, but that's just because I'm clumsy. We're coming now into spring. And we can see that the emissions are, although there's lots of CO2 up here in the northern hemisphere, dying down a little bit. Not quite such dark groups of, this is all slowing down, CO2 being emitted. And things are starting to clean up a little bit even. Because in the northern hemisphere, what's happening are, well, springy things, right? Summery things. Plants are growing. And plants are pulling CO2 out of the atmosphere, using it to build sugar. They're doing photosynthesis, which is cleaning that CO2 from the air. We can see some other pockets where those emissions continue, like in really industrial areas of the world. And we can also see some things like some forest fires in South Africa. Well, not South Africa, the country, but sub-Saharan Africa. Or some forest fires around the globe. Biggest ones are here right now. And these are not related to necessarily just natural disaster. But a lot of these fires, and ones we're going to be seeing soon in Brazil, are more related to clearing land for farming. So the reason that I've got this image up here is mostly to illustrate the fact that when we do things like burn fuels, burn fossil fuels, it emits a lot of CO2 into the air, and that CO2 doesn't cause a local problem, it causes a global problem. If we were to continue along till the winter time again, we'll see the northern hemisphere light back up with lots of CO2. But we won't do that right now because things are choking a little bit. This graph that's growing on the left here shows the difference in how we make energy from the year 1985 to 2019. It's from a couple years ago. And the one thing we can see here, I think I'm just going to flip to another slide and back again. One thing we can see here easily is that things like solar and wind down here, their share is staying low, 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 and in the past 5 years or so, starting to rise. And coal, although it's been highest the entire time and remains highest, is at least starting to plateau our use of coal, and hopefully starting to go down. Although we don't know that for sure. We have to wait and see what people actually do. This little graph here just shows where we get our electricity from on top. Around the world, most of electricity is generated with coal burning. After that, burning natural gas, then hydro and nuclear, and then renewables like wind and solar and other renewables. But if we include all energy, not just for electricity, but also for like moving cars and moving trains and moving ships and heating buildings, this share of oil is the greatest of all. The oil and gas that we burn to ship things and to heat things is great. And our renewables show up, well, hydro and onward, as a much smaller share of the pie. So if you just focus on electricity, you might lose the full perspective. As things warm up, as they do when we have increased greenhouse gases in the atmosphere, we see differences in climate. Here we can see this is just on the other side of the Rocky Mountains from us, pine beetle infestation. And pine beetles are beetles that eat pine trees. And we didn't have them in Alberta for the longest time because climbing across the mountains, getting across that range, the weather was just too cold. But now in Alberta, it's a big concern. We have lots of pine beetles because the winters have been different enough that these beetles were able to survive the winter, make it across into Alberta, and now they have new forests to infest. This is one of the big industries facing forestry in Alberta. Down in the bottom here, I just added a little cartoon. I don't know who drew it. I couldn't find it. But something that you may have noticed driving down the highway in the summertime, your windshield used to be full of bug strikes, mosquitoes, flies, bees. And now not so much. I've noticed this myself too. So not only are we having increased insect populations in things like pests, but also decreased insect populations overall. It can work both ways, and both ways are worrisome. I'm not going to click on this thing here, but I am going to take a snip out of it. So this, I'm going to come back here for a second. Google Earth time lapse. I think it's Earth Engine now. That's a good thing for you to check in on. It's like a time lapse for Google Maps, and you can see what's happened across lots of years. This here is in Alaska. This is the Columbia Glacier, and you can see that over the years the glacier has retreated back and back and back further into the coast. Here, this is one of the big glaciers of the world, the Jakobshavn Glacier. This is near the town of Lillesund in Greenland. And this shows you where the front of the glacier was in the 1850s and so on, back until the most recent date here is 2006. And it's retreating year after year. The chunks of ice that break off this thing are many city blocks in size. They are remarkable to see, but also frightening to see. The scale down here, just for reference, that's 5 kilometers. This is not a small thing that we're looking at. We're looking at a massive change. Greenland is important to look at because it's got a thick layer of ice, and also it's exposed. It's up out of the ocean, not like Antarctica so much. It'll melt first. And Greenland, what we can now see by imaging through the ice is that the melting that's happening, the melting is the red parts. The melting that's happening below the ice sheet is faster than we thought. And that makes the layer underneath. So here's the land, here's the ice, here's a watery layer, a melted layer underneath. That makes the ice slipperier, right? If there's a watery layer underneath, it's more likely for those glaciers to break off and fall into the sea. We can see different images of change around the globe. That Google Earth Engine or Google Earth Time Lapse is a good thing to look at. Here is a lake that previously was quite big and has dried out. Fishing villages that are around the edge of this lake are completely desolate now. There's no fish to be had because the lake is dead. Lots of people's lives have been affected. Lots of fish, lots of wildlife have been affected as well. This is one of those Google Earth time-lapse things. This is in Madagascar. And just taking a look at, I think this region is good to focus on. I'm just going to come back to it again and take a look at the green in this area. Take a look at the forest that disappears. So across this timeline from the mid-80s until a couple of years ago, 3 years ago, big sections of the world, so Madagascar here is a big one. In Brazil, if you look at the Amazon rainforest, or in Bolivia, their Amazon, you can watch the areas that were green turn brown, And a lot of it is not necessarily harvesting wood for building, but rather clearing wood by burning to make farmland. So that's got a double effect, right? Not only are the trees not pulling CO2 out of the air anymore by photosynthesis, but they're also being burned, so they're adding CO2 into the air. They are no longer a sink, and they've become a carbon source. This graph is showing how much of the world is covered in sea ice. Year by year, there's of course melting and freezing, melting and freezing, melting and freezing, melting and freezing. Except for recently, where there hasn't been so much freezing. Which means the global sea ice levels are decreasing overall. And remember, ice is shiny, it has a high albedo, and the less of it there is, the more warmth will be absorbed by the Earth, which means things are going to heat up even faster and even less ice is going to stick around. I know this picture is really blurry, and I apologize. I tried to scale it up, but I failed. This is talking about one of my least favorite topics. Things called methane hydrates, or they are sometimes called clathrates. These are deposits of methane. Methane is natural gas, CH4, that are locked into either ice or ground by freezing. So pockets of gas that are frozen in place. They're all over the world. And as the seafloor or as the tundra warms up, those pockets of gas bubble up through the oceans. Methane is a very strong greenhouse gas, much stronger than carbon dioxide. And as things warm up, these methane deposits are going to melt. They've started already. And as they melt, they're going to bubble up either straight into the atmosphere or into the ocean and then the atmosphere. We've already seen things in the Arctic Ocean, groups of bubbles spreading at one time 7 kilometers across. Bubbles of methane. And that's something. That's a lot of methane. Remember that methane is a really, really strong greenhouse gas. The more of it that's released, the warmer things will get, which means more of it will get released. If you want to lose some sleep, here's a term you could Google: the Clathrate Gun Hypothesis. The idea that once the trigger is pulled and these clathrates start to melt, which I'm telling you, they have started to melt, that's it. You've pulled the trigger. The gun has been fired. Things don't go. The bullet doesn't go back in the gun. So these clathrates, these methane hydrates, can be deposited in the permafrost or in the ocean bed. You can see anything that this methane is created by rotting material. You can see these bubbles come up, and you can see these anywhere that there's rotting material. But where there previously wasn't, where those things were previously frozen into like little sealed pockets, those bubbles have started releasing. So we see that happen at small scale. So here, Abraham Lake, this is in Alberta. These bubbles are bubbles of methane. They're bubbles of natural gas. It's created because this is Abraham Lake. This was dammed. This lake eventually drains to become the North Saskatchewan River to control the flow of that river and also to generate electricity. We dammed this lake a long time ago, 1972. And of course, when you flood something, flood a valley, there's plant material underneath that dies and rots. And as it rots, it's going to release some methane. You can tell it's methane. You can go out to Abraham Lake. I recommend it. It's beautiful. If you go down to Red Deer and then turn right on Highway 11 and just keep driving until you hit the mountains, you'll know when you pass by it. It's big, it's beautiful. It's deep. But you can see these bubbles. And these bubbles, if you pop them and you set them on fire, you can tell that they're definitely bubbles of flammable gas, and methane is the flammable gas that they are. So this is popping bubbles in the ice and setting them on fire. That's what that looks like. It's maybe not the safest activity, but when you burn this methane, you are taking a CH4 and you're burning it. And when you burn things, one of the byproducts is CO2, which is a greenhouse gas, sure, but it's not as powerful of a greenhouse gas as methane. So this fire is overall limiting, decreasing the greenhouse potential of that methane. It is a good thing overall. Now, this graph here shows this is what we think exists in the world. How much natural gas is available, how much oil is available, how much coal is available in the whole world. Or at least what we thought in 2007. I haven't taken a look since then. But this here, this part is the clathrates. This is the part that is methane hydrates, those frozen methane bubbles underneath the ocean. We can see that it dwarfs our reserves of oil or coal or natural gas from other sources. So once this starts to melt, this is potentially quite a big problem. We can see that our levels of methane in the atmosphere have been getting higher and higher and higher over time. Now, increased temperatures, of course, melts ice. That melting of ice leads to, this was animated when I tried it out a minute ago. Come back again. Nope. Okay. It leads to rising sea levels. Rising sea levels lead to displacement. If this happened, so this would be an extreme scenario. But if this happened, places like Florida would be entirely submerged. Florida is a very, very low state. It doesn't have a lot of altitude. And on the right here, I'm just going to leave this with a comment. If you want to pause and read it, you can. This is from a very nice actually webcomic called Bird and Moon. Most of their comics are not depressing at all. They're about birds. But here, just with some direct quotes about how we've known about this problem for a while, but people have definitely worked to minimize it or to act like it's not a problem. Just on the same topic, one thing that I want to particularly warn you about is you've seen maybe billboards or ads around Edmonton from a group called the Friends of Science, always questioning whether the oil industry has anything to do with global warming. The Friends of Science, if you'd like to have a quick, my opinion about it, they are no friends of anybody's. They are deliberately trying to cause confusion where there ought to be none. One of the effects of warming water and changing the pH of water is that the coral reefs are dying, and coral reefs are some of our most productive ecosystems on the planet, home to many, many species that can live nowhere else. We've seen this coral bleaching happening in great big areas across the world, around Australia, most famously in their barrier reef, the Great Barrier Reef. So not affecting just the corals themselves, but also everything that lives in, on, and around them. Having impacts that reach well beyond what I'm able to imagine, I'm sure. We took a look at this in class, or at least some of us have. This look at temperature of the Earth over the past 500 million years. And yes, we have had big changes in temperature, but every time we have a big change in temperature, there is an accompanying mass extinction event. It's a big price to pay. We are on pace for another great big change in temperature, and we are already in the middle of the accompanying extinction event. That's already begun. When water levels rise, we looked at this. We didn't look at it with Florida. It didn't load. But this is in a big river delta. There's the Ganges, the Brahmaputra, and the Meghna river that all empty into the same valley. And this area here is Bangladesh. Well, not just Bangladesh, but mostly Bangladesh. And hundreds of millions of people live there. And that area is entirely a river delta, which means that all of those people, when that delta floods, will have to find a place to go. People, historically speaking, are not super kind about accepting refugees. We'll see what happens in the future. This is something that I expect to see play out sometime during my lifetime if I get to live long enough. I'm not happy about it. This comic is showing the overall temperature, the average temperature of the globe, starting at 20,000 BC. The conditions at that time, this is a layer of ice, this is the modern city skyline for comparison. And we can see that throughout the past 20,000 years, the temperature is gradually increasing, going a little bit above where it is now. We're still at 2000 BC here. We're still quite a ways back. Has some variations, gets a little bit colder, gets a little bit warmer. But the rate of change that we're seeing now is much faster than anything that we've seen in any point in human history. Whoa, I'm zoomed way in here. Hey? So I don't have much to say beyond here. I know this is already 20 minutes long. But most of the things that we would do to combat this issue are things that, in my opinion, and I know my opinion isn't worth very much to very many people, but we ought to be doing anyway. Now, normally I hate like editorial cartoons, but this one was so on the point that I couldn't leave it out. This one just, I have no rebuttal to it. This is all of the things we should be doing for any reason, let alone whether we are trying to combat climate change or not. Okay, sorry this video was longer than I said they would all be short. This one's a little bit longer, but too bad.